Hi, there are lots of ways to work with copper-clad board for circuit prototyping, and I wanted to improve my current basic technique, and this video shows a few of my findings. It's not comprehensive, and for sure there's going to be better ways than this, but maybe it's good enough for testing out portions of circuitry prior to moving to a proper CAD-drawn circuit board. Most copper-clad board is called FR4 and it's fiberglass and it blunts tools. I plan to work with FR2 for copper-clad board prototypes, although this isn't always possible. Asked around and some friends suggested I investigate using an electric engraver, or alternatively a tool that is a bit like a chisel called a scorper but might also be known as a graver. I'm not an expert on it, but I think these tools are used by jewellery makers to cut designs or lettering into metal. The engraver is really low cost, under $20 including some bits, and is 16mm in diameter but has a finger grip area that is thinner than an AA battery, so it's easy to hold like a pen. I wasn't too sure of the quality of the cutting tools supplied with the engraver, so I purchased a separate cutter that is intended for making notches for holding stones in jewellery. Anyway, it works pretty well on the lowest speed setting, and although it might look from the video that the cuts are too thick, this is zoomed in and the width is under a fraction of a millimetre. Using the engraver was a lot easier than cutting thin parallel lines with a craft knife and then trying to scoop out lines, which was my normal method in the past. I think this should be done outside because although the amount of dust is small, it's unclear what the effect of that would be. FR4 is definitely dangerous to health, and perhaps FR2 is safer, but I can't be sure. The Scorpio Tool is really interesting. The entire length of the tool is smooth and blunt, and only the cutting edge at the end of it is sharp, and this would provide a lot more controlled movement compared to a knife, I think, where here you're pushing with the tool compared to dragging with a knife. The tool is not supplied completely finished, and the jeweller would shorten the tool to fit the palm of the hand and then grind and polish the end, and I didn't do any of that because I don't know how to, so probably my results are maybe just adequate. In the video, the surface mount component is 0805 sized, which is 2mm long for size comparison. It was hard to use the tool while recording the video, but I found that if it's held right, then the force used to push through the copper is minimal and it actually feels like slicing through slightly cold butter. I think the tool does need some sharpening to more reliably achieve that level of smoothness, and instead I sometimes found out that I needed to use a bit more force, but still it was nowhere near as much force as I used to use with a craft knife. The tool doesn't slip as much and creates consistent channels, although it will be good to still check things with a multimeter to confirm that there are no shorts before proceeding with the circuit. I also like that this tool can be used anytime when building a circuit with minimal mess. Thanks for watching.